Okay, now the final missing piece. First, what is it? And second, how do we see why we need it? Let me take that the other way around. First, let's see why we need it. Actually, I had written this function down. I'll do it again. I was thinking, maybe this print I could just put into, its own function. We'll call it print. How about that? Print string takes on my string. Saves me a little bit of typing. Okay, so I'll use that for that there. Seems innocent enough, right? Okay, now I'm going to run through the program. And what I'm going to do is to catch the bug as early as possible. You can probably guess what's going to happen. Somebody's going to call a destructor at the wrong time. And you can probably guess who it is. First, step into this part. Now, I'm just pressing step over, all this stuff worked before. Bang. There's a destructor being called here. Now, why is that? Well, let's look at the call stack. It appears as though there was a my string created inside of this function that is now being destroyed. Now that would be okay provided that that string was copied using our copy interface. And so, what is our copy function done? Oh, here it is. So let's see if there's a match. If there's a match with this and this. Okay, that's the one that we had before. So this destruction is happening before any copying ever happened. So this destruction is happening for a string that was created and even has a value. And it's the value that I passed in fact. The two things together. So a copy of this string was invoked. And so the missing bit that we're missing is something that involves a copy and a construction. Because if something's being destroyed, it had to have been constructed. And that thing was a copy of this. So, just like we had to override the default equals, we have to override the default copy and construct operation, which is wrong. Well, I can let this crash. There we go. You can see that. So it's not what we want. We don't want it crashing. Now, it's just a matter of getting the declaration right. This is a constructor. And I should put it actually up higher because it's more important. It's a constructor which takes as its argument another string.
And just like the copy operator, it's the same format. It's going to be a const my string reference. Whether it's on the right or on the left, I don't know. I'll just call it stir. I don't have to call it anything in fact, but I'm not going to define it here. Just declare it. So that there is the definition of a copy constructor. Object being constructed as a copy of whatever okay, I'll name it. A copy of stir. Okay. Okay, put it with the other constructors. There's the default, there's this one, here's this one. As with the other constructors, it's a double up with the my string. Yes, sorry. And similar to the copy constructor, where we're at, fine. Well, there's nothing to free because we're being constructed. In fact, the first thing we want to do, as with a regular constructor, is clear out our variables, make everything 0, and now essentially do the append, which is just the same as this, in fact identical, almost 100% identical to this one. And what we want is stirs string. I want to add something here that you might never see ever again in your life, and you may thank me if anybody ever watches these videos and comes across this line and decides to make it a habit of theirs to always place this assertion in a copy constructor. This not equal to address of string. You may think that that's impossible, but I'm telling you that at some point, sometime, somewhere along the line, somebody's going to make the following typo. We're going to make the typo. It's not that uncommon a typo. Sometimes when you're initializing things, like this my string, you might say my string S1 equals, and then the telephone rings, and I come back and where was I? Okay, S1, right? Okay, done. And then you go on to the rest of the code. Now, what you got here is a copy constructor being invoked of an object that hasn't constructed itself yet. And the compiler allows this. Not even a warning. See? No warnings, nothing. And yet this is completely invalid. And the badness that can happen because of this unpredictable code is something you may never track down without that assertion going off. And it doesn't hurt. It doesn't hurt to put the assertion in the release build. This disappears, but in the debug build, this ever goes off. Thank your lucky stars, because you would never have found it otherwise. Okay. Now, according to theory, this should now be complete. And I'm going to put a breakpoint on our copy constructor here.
And let's see here for our copy operator. And what else? Oh, the destructor. We're gonna need, I could print things out instead of putting breakpoints. Where's the destructor gone? Here it is. Okay, now there's enough breakpoints. Okay. Now we should certainly hit the copy operator here. That all works fine, you know. And append. Now let's see what happens here. See, now we've hit the copy constructor. Taking the string. Now a cleanup of our variables. Set everything to no. Append, which will allocate a new string from here. And we're out. A free. Now that's freeing the copy that was created of our string. But that's okay, because that's not the string that's left over. The string that's left over is still fine. That's stir 0 and stir 1 are both fine. The printout's the same. And there will be 2 more frees. And we're done. Okay? Now, that's pretty good. That covers every possible case of things being copied. It also covers, for instance, this case. Okay. Now, this particular case is what I'm going to show you right now. Well, I lost my breakpoints, didn't I? Well, I can F8. You might think that this would use the assignment operator, but it won't use assignment because it has to build this thing first. So instead, that is using our copy constructor. So that's required for that case. So now we can declare things and assign during the declaration just as we can do with an integer. We can pass things to functions and they return OK. Nothing gets lost, no memory leaks, and there are no crashes. So in a sense, it's perfect. Now, the only thing that's not perfect is our string class. One of the things that you're allowed to do in C++, that's what you've already seeing anyway, is that you can create operators, things like equals, append. Okay, in terms of a string, append is kind of like add and then assign. So I would change the name of this function, not only the name but the return value. I would change this to be an operator plus equals, in this case taking a string. We could also have it, we could also have one taking my string reference like that. But I think we'll be okay with this if I do another thing, which I'd like to do anyway. Stick with this for a second. Now all I've done is a name change. Just gotta find that append, and I'm gonna have to replace other appends. This is the new return value because anything that involves an assignment has to leave
as the result of its operation, the leftmost thing being assigned. I've been using this LPC square to try and be consistent. Okay, so that's all right. Oh, oops, it's not where that goes. So that's my string operator plus equals a regular C string. Now I've used append all over the place here, so now the question is, how am I going to call this thing, which has essentially become a couple symbols when it used to be a nice name? There are varying ways to call it. One way is to, if you don't want to remember any syntax, which I never like remembering anyway, is you could just say this star this. Okay, that's our string plus equals and then this string, because that operation is defined. And recall that this returns a reference to the leftmost object. So we don't need this line. We can just return that, because the plus equals evaluates to star this in the end. So that's in fact fine as a return value. There's another case. If I can find another case, we can use a different method just for fun. We can also call it using the operator notation. We can say operator plus equals like that. The operator plus equals takes a string argument, and so it's just like any other function, it just has a weird looking name. So that's fine as well. And where else have I used append? Here's another one. These ones, I don't care about the return value, so this is kind of better, more concise way of doing it. Any others? Oh yes. Now in this case, this is the reason why I renamed it. This looks quite natural now. String plus equals something, right? It's beginning to look like this string is turning into a kind of integer. Any more? No. Now that should just compile as is. No. I took something away here. Oh, I gotta return. This has to return because the reference to itself, because I changed the return type. Now that should all run fine. Print out the same. Okay. Now that's one type of operator, returning a reference because there's an assignment. But you'll notice, unfortunately, that I can't say, once I have third string. Well, make a new one. Okay. I would like to say stir2 equals stir1, let's say, plus equals stir0. But it's not going to like that. Shouldn't. unless it finds a way. No. Now, the answer is obvious, right? We'll just add another one that takes this type of argument. And that's true. But in order just for interest's sake anyway, what I'd like to do is show you that there's another type of operator which has a different kind of format, and that is an operator which is called a casting or conversion operator. I'm going to define an operator which is whose job it is to convert this object into a pointer to string, like this. Okay? So now I can regard my string type as an actual string. In this case, it should now compile, except for the fact that I have CSZ everywhere. A lot of people say that you shouldn't do this, but I've never run into any problems with it. And I find it saves me a heck of a lot of typing, and I don't have to specify any special functions. If this was to help me with the typing, I don't need anything to help me anymore. And it should compile, yeah. You see, now what it's doing is converting this into a regular C string, and then using the plus equals that are already defined above, and calling something like put s is just a matter of calling it as if the thing were just a regular string. And you see it works. If I put a breakpoint here, or here, let's say, anywhere, here on this put s doesn't take my string values, but when I press F8, it's converting my string into a C-style string in order to be able to give that to the put s function, which it calls with the string. Okay, get out of there. And there you go. So now we have just by changing this, not only do I not have to type the .css, but I added an extra function immediately to the class, free function. Now the other thing is, that we can throw away this constructor if we wanted to. It's possible, anyway, to take this away, because if I passed in a string value, it's just going to use this constructor instead. I'm going to just get rid of it. I'd like to have it there, really, but especially for the, whoops, no, I definitely need it. I need that one. It's this one I can throw away. Anyway, so we need the copy constructor. That's different. Anything else that's changed from that? What else could we add? One thing that I'd like to add to any string class, and this one in particular, is something that looks a little bit like those IO stream arrow things. And those things, although they're not very useful with the IO stream stuff, can be quite useful for a string class.
if we can find a way to sort of create a variable argument list type printf type function for the class, and then we can, the goal would be to be able to say my string I'll declare it here. Like this. These sorts of things. Actually, this would be a wrap. I forget exactly how you would declare this. Something like this. Maybe that's exactly correct. And then you can just build a sort of a table of the various types of things that you can just easily convert into strings using these arrows. And you'll find that that's quite handy to have, especially for printing things out quickly. You know, if you want to see this rect, you don't want to write printf bracket %d, %d, %d. It'll just be that. It'll just be a single line thing. And the key to making that magic happen, and not only that magic, but adding the ability for any other class or type to add itself to the chain of things that can be arrowed into strings can be added as well. But we don't have to add those things here. Anything could just define the correct double arrow function and then add itself to this chain of things that can be turned into string representations. So that would be another thing to add to this. Oh yeah, lastly, just to show you the difference between plus equals and plus. This is what plus would be, okay? Plus and const. When you add a string to a string, okay, and I might need one taking my string as well. There's no assignment going on here, so instead this string plus this string will get added together, and then a new string is created and returned without modifying this. We can implement that quickly with the other one. In fact, I could probably just use that code, even though the other one's not const. That doesn't matter because I can get around that as follows. I could make a my string made from myself from this. Let's use the constructor directly. Okay. And then return stir plus equals. No, I don't want to call it stir. I'll call this C stir and this stir. I think that should work. Stir will be is a totally new string, and it will get modified by being appended this value, and then returned as a new string. So that should compile our work. Okay, let's try and make it happen. Stir0 hello equals stir1 plus that. So now we have that ability. Okay, that has the same. What did I have? Plus e. No, it is different. Stir1 is no, it's not the same. How about this? Now, is this going to work? I think we may need to add a new. Yeah, we need one now on the left hand side. Something that can a string plus a stir1. And that's not too hard to add. It's a my string operator plus takes on the left a regular string and on the right a my string ref. Now this is not inside the class here, so I need to specify everything. Now, can I implement this with what I've got so far? I can turn this into a my string. Right? And this is a my string. I'm allowed to add 2 my strings. That should do it, I think. Well, it's not unique enough. Could be this one or this one. Plus let me make this plus equals instead. That'll do it. Looks like it worked. My question is, what does this print? Stir1 at this point should be a breakpoint. Stir1 is, this is my string, so it should be, this is my string. Now I'm going to step through it, so we'll see what happens. Which is, how is the addition? How are the additions organized? First, it's adding the to this part, so it's doing the left one. And there's a cast. And then this constructor bit. Okay. Now this is the plus of, and here's some more plus this, which has already been appended. Okay. So the total result is that. So now you see what I'm talking about with these operators. Essentially, we've turned this string thing into an int. We add them together. We don't have problems with memory leaks or anything. We can pass them to functions. We can add them together while calling a function. That function doesn't even take my strings as arguments. Will be converted into the appropriate format for this function, and all that happening automatically, just all through this simple conversion and some extra bits. So that's why I find this conversion to be useful. I don't know why people say that you should never do that. I feel the opposite way. I've never had a problem with it. It's only ever been a bonus for me. Okay, so I don't know what's next, but I'll think of something. Bye-bye.